Hello everyone and welcome back to Java. It's been a long time because the holidays happened, then I got a head cold and I tried to do a video for a gaming channel I do and it sounded like I didn't have a nose. So at any rate, we are back. The problem of sounding like Voldemort is now gone and we're back to Java. So a couple of housekeeping things real quick. One, this is tutorial number 17. We're going to be talking about the ACM graphics library, which is a really easy, fast way to do graphics. And it's the way I prefer to doing native Java graphics, and in fact, I've hardly even done much at all with Java graphics, because ACM is just so much easier to use. It's not quite as powerful, however, you can get all the logic and stuff down, and then if you want to go on to native graphics, it's easier because you already understand kind of the program logic and the way that these don't work in quite a linear fashion, which we'll get into, we'll explain, and it'll make sense. So, other housekeeping items, two items. We're going to be starting a new series, actually two new series, and the first one is going to be on developing bucket plugins, how to make a nice bucket plugin, real simple and together, and the reason we're doing that is to kind of learn how to apply these skills we've already learned into a real life situation, which is, many people say, oh, video games, those are phony and whatever, and no one cares. Well, honestly, they're a huge market, they're a lot of fun, and I like them, so why not use them as an example for learning? So we're going to be making plugins for the Minecraft server bucket. It's a kind of server mod type thing, and you can make plugins for it and do all kinds of cool stuff. We'll be making one that spawns a treasure chest with stuff inside of it. It's already on bucket.org, actually. I've already published it. I haven't made the tutorial for it yet or anything, but it's already been published. I made it about a week and a half ago, 10 days ago. And it's called Treasure. If you just go to bucket.org and click on Get Plugins and search for Treasure with capital T, it should be the first result. And it doesn't have many downloads, not really expecting much, but just kind of a fun thing. I was like, hey, I'm going to learn how to do bucket plugin development, so I made that. And we'll be making that together, actually. Making basically almost the exact same thing that's there, maybe a couple minor modifications, and then we'll be going on to other plugins, maybe from either ideas you guys have, or just kind of things that I find on the forums that people are requesting, or whatever. We'll just work it out. So we're not going to be getting too advanced too quickly there. We're going to try to take it easy, go in and just kind of wiggle our feet in the water, figure out, what's going on, how does this work, and this is actually kind of a nice lead into that as far as the basic program logic of how things happen in a non-linear fashion. Or at least appear to happen in a non-linear fashion. How that works, how you deal with it, how you manage it. The second thing is we're going to be starting a tutorial on Linux. Oh, by the way, the Bucket tutorial probably next weekend, and then Linux tutorial probably 2 weekends after that is when they're going to start. The Linux tutorial series is going to be on, it's going to be real short, maybe 4, 5, 6 episodes probably. And it's just going to be how to buy and manage Linux servers through SSH. Things like Apache web servers, things like installing Java and running a Minecraft game server. We're going to be going over just basic types of things you may be interested in finding out. So, without further ado, let's get started in today's tutorial. And so, the first thing you got to do is you got to download the ACM graphics library. There's a link in the description below. Trust me, it's real easy to integrate it into your development environment. In Eclipse, for example, I just right-click, go to Properties, go to Java Build Path right here, and go to the Libraries tab. It'll usually be right there. I'll go to the Libraries tab, and then you just click on Add External Jars and browse for your ACM jar. Click it, click OK or Enter or Select or Choose or whatever it has, and then it should appear right here. And if you open this up, it'll show you some of the things that have to do with it, although ACM doesn't provide source, nor does it provide JavaDocs, nor does it come with native library locations, and no restrictions on access rules, so whatever, we don't really worry about that. We're just worried that it's there. And it is. So we're starting with a couple of imports, acm.graphics.wildcard, acm.program.wildcard, and acm.util.wildcard. We may have to introduce some other imports as we go. That's no problem. We'll just add them as we need them. So we create our class, and it's called main class, and it extends graphics program. Graphics program is a class, an applet inside of the ACM library that we're basing our application off of. And what it does is it provides the basic framework for adding graphics, manipulating things, key listeners, mouse listeners, things of that nature. It has them already. Sorry, let me drink some water real quick. That's better. It basically has all those integrated into it, and so we extend it so that we can build upon it. Remember, the extends keyword is like a, basically, in quotes, is like a blank except, end quotes. So we'd say main class is like a graphics program except, and then whatever's in here is why it doesn't behave quite like a graphics program. Well, we add on top a graphics program to improve it, and in this case it's to make our own application on top of it. In other cases it can be something as simple as extending, say maybe forking source code that someone else has made to serve another purpose, things of that nature. Maybe a fork from GitHub, something of that type. So, or it could be something like this, where you're extending a pre-made library to build on top of it. So we have a couple, I've already pre-done this because it's just kind of repetitive task type stuff. Oh, real quick, to show you what's possible, I almost forgot, with ACM, here's a quick little brick knockout demo I threw together. You can read that if you want, you can pause it and read it, but basically it just says, hey, it's brick knockout. And so as you can see, the paddle follows the mouse. I click to release the ball, and then I just hit it, and it hits bricks, and the bricks' colors change until they get to cyan. They go from white, red, orange, yellow, green, cyan, and then if you hit them while they're on cyan, they break. If you hit the side of a block, and this is actually in the spirit of, it's not a bug, it's a feature, if you hit the side of a block, it'll like glitch through the block sometimes, and give you like mega bonus. Like that. Perfect. Great timing there. Anyway, it'll basically just glitch through that, and the reason is because we're moving more than one pixel at a time, so the collision detector sends it in another direction and then checks for collisions, and it's like, oh, it's still in the block, and so it freaks out and just spazzes out and has fun with it. But that's something that could be fixed. It's a basic example. I don't feel like going in and fixing everything and making the physics perfect and all that. So, but this is just an example of what can be done. We're probably not going to get this advanced unless people are really interested in it. But this is, if people are interested in the source code, I'd be happy to post it. It's just a real simple little thing. It's fun to play. It has infinite levels and currently infinite lives, and you just play through it, and they're randomly generated, but they use the same seed, so it's the same game every time, and at the end of each level it tells you your score. Now, this is taking quite a while to play through, so I'm just going to quit while I'm ahead and go back to programming. But it is pretty watching the colors change. So that's what you can do with the ACM library. So we're going to be showing you the real basics. This is just going to be a real general introduction, how to use it, what it does, show you a couple small examples, and then in 18, 19, and 20, we're going to build tutorials 18, 19, and 20. We're going to build upon that knowledge, make things, check for collisions. We're going to be doing images, maybe even like text that changes, and maybe even like selection buttons and stuff on the side. We're going to be doing key listeners where we're listening for events and, cheat codes typed in and stuff. It's going to be fun. We're going to be making a real simple little game, like maybe a Frogger type game, something of that nature, of course with 2D graphics and a lame turtle. However, so our run method here, inside of it we're going to add mouse listener, caps, add mouse listeners, and add key listeners. Those are both methods of graphics program, and they're yelling at me. Add mouse listeners. Oh, capital A. I was like, what did I do wrong? I spelled everything right. One time I spell everything right, I capitalized something wrong. Gosh. Add mouse listeners and add key listeners tells the program, hey, tell me whenever they either move or click the mouse or whenever they press or release a key. So we'll be talking about that and how to use those. We probably won't be using mouse listeners today, probably just key listeners, keep it simple. And we'll have like some kind of switch statement for handling those. Drink some more water. Here, I finally figured out how to go through long tutorials without my voice cracking up. I think the answer is water, although we'll have to test that theory. So, add mouse and key listeners, and then we're just going to add a real simple little blue rectangle, cyan. So we do grect, rect equals new grect. And we got to give it some parameters. The parameters are going to be the width and the height. Some people say width and length, whatever. 2 dimensions that imply size, basically. So let's do 30 by 30. That should be good, and let's just run it real quick and show you what it does. It's real small right now, and for this tutorial we're just going to stretch it. Next tutorial we'll talk about actually using this window height and window width to bring it to actually make the window that size. Actually, set size, I think it's, yeah, set size int, so we do window width, window height. Might as well just do that now. It's really simple. And then if we run it now, it's still the same size, but it expands once it finishes kind of starting up. So 800 by 600 I think are just good dimensions. We can go in and change that as necessary. So grect equals new grect 3030. And so that's the size. If we gave it 4 parameters, by the way, there's great Java docs. There's a link in the description below to the ACM library download. There's also a link to the ACM Java docs, which are just great for looking stuff up, seeing what's available to you, and utilizing it, finding out how to utilize it. So if you look up there, or I can just tell you now, if you make a grect with 4 dimensions, it'll be like the starting and ending points of the rectangle in the window. Like this, it makes it at the origin. We'll talk more about that in just a minute. Drink more water. I'm going to need to get more water soon. So you have a rectangle, and we want to do something with it. So, just to start, let's do rect dot, and look at all the stuff we have. We want to do set location, and we can either do a G point or 2 doubles. 2 doubles are easier. You may want to use a G point if you're getting the location of something else, which returns a G point object. Again, you don't have to know what that means. We'll get into that later. Set location, let's set it to 300, 300. Now, even though we have a rectangle, you'll notice if I run the application, we don't see the rectangle yet. It's because we have to add it. So, we'll just do, why is BlueJ open? Don't need BlueJ open. We'll do add rect to add the rectangle to the window. So let's run that real quick. And boom, it's right there, outlined in black. We could do, before we do that, let's set it to blue, because I like blue. Rect dot, and we'll scroll down to set color. And color dot black. Color.black is, why does it matter to me? Oh, I have to import java.awt.color. Okay, we're good. Anyway, color.black is a constant in the AWT package, and it just refers to, blue. What part of blue does my brain not understand? You're basically setting the color to a constant. That constant is a number that refers to RGB values. RGB, remember, is how, well, maybe not remember. In case you don't know, RGB is how computers describe color. They can also work in CMYK, but RGB is much easier because your monitor is RGB. Your monitor, each pixel, is a combination of red, green, and blue. And you can combine those colors, those 3 true primary colors, when you're working with computers, to make any color you need. Black is no exception, and so it knows what values of red, green, and blue refer to black. And this is an exact black, I guess. Or blue. I don't know why I keep saying black. Blue. So let's run this. And you'll see it's outlined in blue, but we want to fill it. So you have to also do rect.set fill color. That better work. Doesn't work. Rect.set let's see, set filled true. I always forget to do that. So you have to set that it's filled to true, or else it'll just show an outline. Then you got to set the fill color. By the way, this is the default color. If you don't set a color, it will default to the color of the outline if you have an outline. So just little tidbit of useful data. So we'll set the fill color. And in fact, we don't really even need to do that. And just to experiment, let's set it to green, run that. We'll see it outlined in green and filled with green. So if we want the fill and outline colors to be the same, we can just set the outline color, the set color, and then set it to filled. Add rect adds the rectangle to the screen. and then allows us to manipulate it. So we're going to create a while loop, while true, which means it's kind of an infinite while loop until you forcefully quit the application. And this loop is going to repeat every X amount of seconds, that number being 0.05 seconds, which gives us a frames per second rate of 20 because of this refresh here. So we'll do pause, refresh, and that's pausing for the refresh time. So it pauses, every time it runs this loop, it pauses for 50 milliseconds before it runs it again. So pause, 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 pause. However, this does mean that if your application does a lot, then you may end up with a couple less frames per second than 20 because you're having to do that math, then wait 50 seconds, do that math, then wait 50 milliseconds, do that math, then wait 50 milliseconds. So you may want to tune it based on your application's performance. Just FYI, throwing that out there. Good to know. The more you know, the more you calls. So we're in our while loop, and that just keeps on running and running and running. And inside of here, we want to do stuff. So let's say while true, let's add another rectangle that slowly moves across the screen. So rect 1, 1, 1, 1, 1, and then we'll make a number 2. So grect 2 equals new grect, and we'll make it 10 by 10. Okay, it's small, so I'm going to make it go fast. Rect 2 to compensate. Set color dot red. I like red. And rect 2 dot set filled true. Nah, let's not. Let's just have it as an outline. And add rect 2. So now if we run our program, you notice you only still see the green square. That's because the red is behind it. If we reverse, close. Stop running. If we added rectangle 1 before 2, you still don't see it there. Close. Takes forever. So anyway, let's try setting our location to something else for rect 2. Let's do rect 2.setLocation, and this is my little spiel on the origin. You'll often put objects in, and you're like, where to go, where to go, and then you reverse them, and you're like, oh, this way it'll show on top. Wait, where to go, where to go? It's at the origin, which means it's at 0, 0, which means you can't see it. So you got to set it somewhere where you can see it. So let's do set location for 100, 100. Something simple like that. Now let's run it. And ta-da, we now have our little red thing, and we have our green box. Now if you make a big rectangle and set the origin, part of it will just be cut off by the window. But if you make it small, the origin's right up here, so it's not going to show, it's going to be hidden. So anyway, we have our rectangle there, we have this one here, and I think what I'll just do is a very simple program where you control the green box with the arrow keys, or WASD, and you try to like grab the red box as it goes across the screen. Just real simple, obviously, doesn't take much skill, but hey, we are trying to learn how to do this, not how to make the next killer app yet. So, in here, we'll every time it refreshes, so 20 times per second, we will move that rectangle to the right 1 pixel. So, rect2.setLocation, and then rect2.getLocation dot getX. That's why I love Eclipse. It's just so easy to just do that. So getLocation returns a gPoint object, or a location object. From that, you can call the getX method to extract the actual X value out of it. The reason we're not setting it to just getLocation, because that's a location object that we could use, is because we need to manipulate it. And we could do location.setX, blah, blah, I think, but why do that when it's just easier to do it this way? Actually, if you do get.location it should be set location, we could set the location to then getting the location again, but that's just redundant and silly. So we're doing .getX plus X is your left to right, Y is your up and down. Positive Y is down, positive X is to the right. So we'll add 1 to x every time we refresh. rect2.getLocation.getY, and we'll just leave y alone. Yeah, so let's run this real quick to see what it does. Bloom, and you have this box that's very slowly moving. Close. So if you change this refresh to say 5, what happens? The box goes faster. It's going actually 10 times the speed. And we want something to happen where when it goes off the screen, it goes back to the start. So we want to do if rect2.getLocation.getX, a conditional value. If x is greater than our width is 800, if it's greater than 800, or let's do 790, that way it just kind of like bloop bloop. It doesn't hit the edge all the way, it just kind of touches it and then goes back. If that happens, then rect2.setLocation, rect2. 0, and then rect2.getLocation.getY. Okay, so we set it back to 0, left and right, and we set it to the y value it previously had. So let's run this again, see what it does. Goes all the way across, and it should flip back to the other side, and boom, it works. Let's watch it real carefully. Boom, and come across. If you keep your finger on the screen, you'll see it's going past the same point at every time. It's not at all changing in y value. So it looks like we have the first component of our game figured out. Now we got to move this box, this green box with the arrow keys. So we already added a key listener, but we need to respond to the key event. So the way you do that is you create a method that the ACM library, basically, essentially, calls every time a key is pressed. And this is what is interesting about this graphics application type programming as opposed to something like a text game programming. In here, you have a difference in the logic because in a text game, you'll usually see it follow a real linear flow. If blank, then blank, if blank, then blank. In here, this while loop can be running, because it's multi-threaded, while we have a key listener calling events in the same class. So this class can be listening to key listeners and doing stuff with key listeners as it's refreshing the image. So, without further ado, we have just really a really simple multi-threaded application here. And we've already talked about multi-threading, but not in this way. It's a very similar concept, though. So we'll have another method called public void key pressed key event e, and then there's a subsequent public void mouse moved event and mouse button event or mouse click event. And it's telling us about key event. We have to import it from java.awt. And what this does is whenever basically the graphics program inside of it listens to key listeners, and it gets those key listeners from the Java's AWT package. So AWT listens for key events, passes them on to graphics program, and graphics program, since we extended it, gets that information sent to it. So key pressed will be called by the AWT library whenever someone presses a key. So we're going to do a switch statement, switch e.getKeyCode. So E is our key event, so whenever I press a key, a new key event is created, and e.getKeyCode tells me what key press made that event happen. Sorry, more water. Alright, so we switch based on e.getKeyEvent, and inside of here, we'll do a couple cases. So case key event.vk_up. VK is virtual keyboard. Even though it's a physical keyboard we're typing on, we consider it a virtual keyboard because AWT is getting that and mapping it to a keyboard internally. And vk.up is just a constant. It refers to a constant that is basically refers to the up arrow key. Now we can also do it with letters, so vk._w, for example. And so if we switch on that, it's going to yell at us again because case, blah. It shouldn't be yelling at us about that. VK underscore W, insert, oh, right. Silly me, that's not a semicolon, that's a colon. So VK underscore W becomes a constant. Let's see how they don't want to explain it. Okay, and we could also do up. Either one works. So I'm going to do WASD. I have my left hand on WASD, my right hand's usually on a mouse while I'm gaming, so I wouldn't want to use arrow keys. That's, no, not fun. So key event W. And when that happens, we want to do rect. We want to actually create a set a boolean, something like W is down to true. That way, every time this while loop runs, we can actually. Let me key event dot. Basically, key released is going to, well, key release, the way they explain it, the key released event, the event is generated when a key is let up. We could use that to make it so when you're holding down the button, the thing moves. So we could say case key event blank whatever equals whatever, and we could basically switch based on when that key is pressed and released. Or we could make it so that it has a constant movement, and by doing WASD, you're switching the way it's moving. And that's what I'm going to do now, actually. So I'm going to do VK underscore, whatever, VK underscore W. And I'm going to have a public static, no, not final, public static string direction. And it's going to be at first set equal to down. We're going to start going down. And when while runs, we will do another if thing here, that, if direction dot equals up, do this, down, do this, whatever. And so we'll add that in just a second. But first we got to change this string based on what key is pressed. So case key event dot VK underscore W, and we'll do direction equals up, lowercase, up. And then we'll do another case key event dot VK underscore S would be down. So direction equals down. We will do another key event, VK underscore S. It's mad at me because I put a semicolon, because I'm silly. Case key event dot VK underscore D would be right, so A would be left. Direction equals left. And finally, we handle right. Case key event dot VK underscore D. Direction equals right. And that's all there is to it. Except we have to spell right correctly. So, or we'd at least have to take that into account in here. So if direction dot equals up. The reason we do dot equals instead of the double equal sign is because the double equal sign is for primitives. If you have literally up equals up, it'll always return false because they're different objects. Even though they have the same value, they're different objects. So you have to do dot equals, which looks at the actual value inside of the string. Well, in what this case is a string. The object composition. So, if the direction is up, we want to rect2.setLocation. And if it's going up, we're going to want to keep the same x, but change the y. So rect1.setLocation. rect1.getLocation .get x, that's fine. rect1.getLocation.get y, so we're getting the y location of the rect, plus 1 because we're going up, so we want it to, or minus 1 because we want it to go up. So let's just test this real quick. If we're in our applet and we press the up W, nothing happens. Press the other keys, nothing happens. Why is that? Well, if we stop our program here, we can go through and look at the logic in here. So we have direction equals down, dot equals up, set location, y minus 1, everything there looks fine. and vk underscore w direction equals up. So everything seems fine inside of our code. So the best way to do this is to add, first of all, I forgot break here. Break, oh, what am I doing? Break, break, and break. Common mistake, even I fell victim to it. So now let's try again. W moves us up. Now we haven't implemented the other ones, so when we press them it just stops moving. When it goes off the screen it should go back to the bottom. Not going to worry about that logic in here. Maybe next episode. It'd be pretty easy to program. You just say, in that while loop you say basically if that puts it over this or under this, then change to this or this. It'd be real simple to implement. So probably next episode we'll do that. We're running up against time, 30 minutes. That is way too long for an episode, to be honest. But else if, let's do this fast. Yep. If direction dot equals down, then rect1 dot set location, rect1 dot get at, you know what? Copy and paste. Copy paste is your best friend as a programmer. That plus Google. So we have those two. Now I'll copy this 2 more times. Direction left and left and right. And so for these we'll want to alter the x. So left you'll want to do x minus 1 because going to the left x gets smaller, going to the right x gets bigger. And for the right you want to do plus 1 and get rid of this funny thing on y. So let's also add a character case key event dot vk underscore space. Direction equals stop and break. So if we stop it, then it's not any one of these, so by default it'll just stop moving. So let's play our little game real quick. Bloom, 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 up, down, left, right. It seems to be working fine. Space stops it. Pressing space doesn't, of course, resume it. You have to go back to pressing the arrow keys. And we don't have any collisions set up yet. That'll be the next episode, I suppose, because we're running up on time. As you can see, collisions do nothing. One just goes over the other one. And we also need to do either something that prevents it from going outside of this border, or something that sets it back to the other side, or sets it to a random location, or whatever. So that's all for the tutorial today. Thank you for watching, and the source code is also on a download in the description below. So everything's in the description, moral of the story. And I hope to see you for tutorial 18, which will be coming out soon. Thank you again.